Today, section 5.3.2, so it's the second half of section 5.3. We're going to talk today about the altitudes of triangles. If you recall last week, we talked about medians of triangles. Alright, medians of triangles. If I drew a triangle up here, let's recall some information. What does a median mean? Median means it goes from the vertex to the opposite side. What though? What about that opposite side? Vertex to the opposite. If you think median, what do you think of? Middle. So a median is a vertex to the opposite midpoint. Okay, that is a median. Vertex to the opposite midpoint. That is a median. However, an altitude, a way to think of an altitude is to think of, let's think of this in English terms or just in regular vocabulary terms. When you think of altitude in real life, what do you think of? Height. Awesome. Best answer. Altitude is another way to say height. A lot of times people think of plains when they think of mountains, somebody said earlier too. And why you think of plains and mountains? Because you think of height, elevation. Altitude is height. Okay, that's kind of another way to think of altitude. It's a height. Vocabulary, again, we talked about the first two last time, medians and centroids. The median is a segment whose endpoint are a vertex and the midpoint. We just talked about that. Centroid, again, is the center of gravity. It's the point of concurrency for the three medians. We just talked about that as well. And here's what we're going to talk about today. We're going to talk about an altitude. An altitude is a perpendicular segment from a vertex to the opposite side. So it's a perpendicular segment. Basically, if you were to measure the direct height from one side to the next vertex, you would go straight up and down, and that's what we're doing today. We're doing the altitude. So here's kind of an example of what it would look like. So if I have that triangle right there, that red line would be my altitude. Okay, that is the altitude right there of that triangle. That's an altitude of that triangle. And again, it's an altitude because it's a perpendicular segment to the other side. So it goes from one vertex to the other side, perpendicular segment. The orthocenter is the point of concurrency of the three altitudes of a triangle. So it's the point of concurrency of three altitudes. Now, the orthocenter can be either inside, outside, or on the triangle. All right, the orthocenter can be inside, outside, or on the triangle. It's kind of unique. Whereas, let's think about the centroid. Could the centroid ever be outside the triangle? No, center of gravity is never going to be outside that triangle, right? Center of gravity is always going to be right there. So that's what's kind of unique about that. All right. Here's what we talked about the other day. These were the centroids. Now remember, centroid was 2/3 the distance. So for example, this distance here is 2/3 the whole distance, whereas this distance is 1/3. Okay, we found the different distances in centroids. So there's the centroids of a triangle. Here's what we're going to talk about today, though, and that is the orthocenter. The orthocenter is the point of concurrency where the altitudes of a triangle intersect. So it's the point of intersection for the altitudes of a triangle. Now, a couple ways to do this and to think about here, okay? I have a triangle down here. Triangle A, B, and C. Now, we just got done talking about vertical and horizontal lines. If I have a vertical line, like the red line is there, what is always going to be perpendicular to a vertical line? A horizontal line. So whenever you're doing orthocenter, you always want to look for vertical and horizontal lines first. Why? Because it's a lot easier to find the perpendicular line. Does everybody agree with that? For example, does everybody see how they find the ortho, or not the orthocenter, but the altitude there? Yeah. Okay, if I have a vertical line, well, my horizontal line now, right there, that's my altitude. So I have one altitude right there. Now there's a couple ways to do these. I'm going to show you how to do them all by graphing because it's a little bit easier to visibly see the orthocenter when you're graphing it. So in order to find that, now again, altitudes, they're perpendicular segments. So we have to think of perpendicular slopes. Well, they found the slope of AC. Okay, so one was they find the slope of AC here. If I'm thinking of slope, what's another way I can think of slope? Instead of the slope formula, what's another way to say slope? Very good. Slope is rise over run. So from going from A to C, I could go down 3 over 6, giving me a slope of negative 3/6. Is that the same thing as negative 1/2, Tiana? Yeah, you bet. I can get the same exact slope just going rise over run. I don't have to use slope formula all the time. Well, again, now I'm thinking here, I have to think perpendicular. So what's the perpendicular slope of negative 1/2? That would be 2 negative reciprocals, right? So I think 2. So again, a couple ways to do this were, well, I'm thinking of a perpendicular line through this vertex. So from B, I could go down 2 over 1, down 2 over 1, down 2 over 1. And I get my perpendicular segment, or my altitude. Okay, so using perpendicular slopes, I can find the altitude. And then from there, I locate the coordinate. Well, they intersect at this coordinate right there, which is the coordinate 1, 3. Now, if you don't like doing it by graphing, well, another way is you can write the equation of the line and then use systems of equations, a review of algebra. Remember solving systems of equations by either graphing or substitution or elimination. Kind of a bit of a longer process. I would definitely choose to probably do graphing. It'd be a little bit easier, and you have to graph it out anyways. Okay? So let's go step by step through one and find the orthocenter. The orthocenter here. So triangle FGH has coordinates F, negative 3, 1, G, 2, 6, and H, 4, 1. It says find an equation of the line containing the altitude from G to FH. As you look up here, as you look at the triangle, what type of line do you notice right away in that triangle? I see a what type of line? I see a horizontal line. So I know my altitude then has to be a vertical line. Nice job. So here's my horizontal line, which means my vertical line would then be right there. Nice job. That is one of my altitudes then. There's one altitude. Now, review here. We just got done talking about it in the warm-up. What's the equation of the line for that altitude? If you were to say the equation of that line, it's a vertical line through what coordinate here? What's the equation of that line, Emily? Nice job. That is x equals 2. Because it's a vertical line through 2. Good job. Now comes the next part. I'm going to do FG here. Okay. I'm going to do FG right there. I want to find the slope of FG. Okay, I want to find the slope of FG. What's one way I can find the slope of FG, Suitor? Good. How many up we're going to go?
6.
5. Over how many?
6.
5. I believe it's up 5 over 5, right? Which gives me a slope of what then, Suitor?
1.
Good. Could have also gone up 1 over 1, up 1 over. Could have also done that as well. Yes. Right? So slope is 1, which then means my perpendicular slope is what? If my slope is 1, the perpendicular slope is going to be what, Ezra? -1. Good. Does everybody understand what we're doing so far? We found the perpendicular slope. So when I'm looking at this green line right there, I want to draw the altitude to this green line. What coordinate am I going to use? If I'm going the altitude to this line, which coordinate am I going to use? Am I going to use F, G, or H? I'm thinking altitude. Altitude is vertex to the opposite side. So which side is opposite of that green line? H. I'm thinking H there. Does everybody see that? Because altitude is vertex to the opposite side. That's the altitude. Now I'm going to go with that coordinate. And what slope am I going to use from that coordinate then? I'm going to use the perpendicular slope. So from that coordinate, I'm going to use my perpendicular slope. And I'm going to go, now usually when we have negative slope, we always go down and over, right? So what's another way we can think of it though? I could go up and left. So I can go up one, left one, up one, left one, up one, left one, up one, left one. And I go the whole way and I get a line that looks something like this. So now I have two altitudes. I'm looking for that point of intersection right there. Where do they intersect at, Nathan?
They intersect at 2, 3.
2, 3 is correct. Nice job. So that's what we're looking for. We're looking for that point of intersection of the orthocenters. Again, look for the perpendicular and horizontal lines first, then find one of the other slopes or altitudes. Let's try another one. All right, I have triangle DEF here. Number 11 says plot D, E, and F, and then draw the triangle. So I'm going to plot the triangle. So I have D is at 0, 0. E is at 3, 6. And F is at 4, 0. And then I fill in my lines here. There we go. So there's my triangle. What type of line do I notice I have right away, Amy? I have a... Yeah, I have a horizontal line. What's going to be the altitude to a horizontal line then, Amy? Yeah, it's going to be x equals. But what type of line would that be,
X, I don't know.
I have a horizontal line. Perpendicular to a horizontal line is a vertical line. Do you agree my altitude to be something like that right there? I agree. What's the equation of that line then, Amy, which I think you're going to try and say? X equals?
3.
X equals 3. Good job. Is everybody good so far? That's going to be the easy part today. Always finding that vertical and horizontal altitude. That's the easy part. Okay. Next says find the slope of ED. Well, here was D, E, F. So next part says find the slope of ED. What is the slope of ED? So here's ED right there. There's ED. What's the slope of ED going to be? Tech, what's the slope? Rise over run. 6 over 3, which is really 6 over 3 is really just 2. Or 2 over 1, either way you look at it. Which means, what's my perpendicular slope going to be then, Emily? Negative reciprocals. What? Negative 1/2. Right? Negative reciprocals, negative reciprocals.
Wait, where'd you have?
The slope was 6 over 3. Which was really just 2 or 2 over 1.
Yeah.
And then I flipped that. You good? So to that green line, which vertex am I going to use? D, E, or F? I have 3 vertexes to choose from. To the green line, I need to make an altitude. Which one, Isabels? F. Very good. So I'm going to take coordinate F. And which slope am I going to use from coordinate F, Isabels? Which one? If it's going to be perpendicular, I need to use that perpendicular slope. So I'm going to use -1/2. So from F, I'm going to use a -1/2 slope, which means I'm going to go up 1 over 2. Or sorry, up 1, left 2, up 1, left 2. And I get a line that looks something like that. That is my altitude now. Again, altitude is a direct height to the distance, perpendicular segment. What is the point of intersection there? Now, I know it's tough, it's kind of in between, but it's right where you'd think it would be. Where do you think that intersection is, Tiana? Not quite 1. It's a little less than 1. Where do you think it's about? Yep, 3 1/2. That's the only one to say you have a fraction. All the ones in your assignment are no fractions, don't worry. Okay, 3 1/2 is correct. Nice job. Again, find the slope, perpendicular slope, find the altitudes. Okay, try this one on your own. I will tell you right now, you will have to add a few lines to the top here, so they are a little short. All right, let's walk through this here. I think a lot of us found our perpendicular height right away, right? That's good. So the first one is right here. There's the perpendicular height for the... There's my first altitude. Everybody's good there, right? It's the other one. You need to find one of the other slopes. Does not matter. Which slope did you want to find, Emily? A to M? That slope right there. Great. What's the slope for AM there? What? Up 1 over... Isn't it 1/2? Okay. Which then means my perpendicular slope is what, Emily? -2. So from what vertex do I need to go with a slope of -2, Emily? X. So I need the one opposite of the slope I picked. Opposite vertex, opposite side. Those are altitudes. So from X, I'm going to use a slope of -2. So I'm going to go up 2, left 1, up 2, left 1, up 2, left 1. And I get a point that's there, and I get a point that's there. My altitude looks something like that. Now I'm looking for that point of intersection, which is right there. What's that point of intersection, Amy?
Point of intersection is 1/5.
1/5. Nice job. Okay, I'm going to give you another one here. This is a thought-provoking one here, okay? So using that same grid, we'll call this number 17. We'll say A is at, let's go with 0, 3. M is at 0, 0. And Y is at 4, 0. Where would the orthocenter be located here? Take a couple seconds, think about it. All right, so as I look at this triangle, first of all, what type of triangle do I have? It's a right triangle. Do you remember what we said altitudes were? Weren't altitudes just heights? Right? So as I look at that triangle, where do you suppose my orthocenter is going to be located? Hey, if I were to draw an altitude from A right here, what type of altitude would that be? Where'd it go? Straight down. If I were to draw an altitude from right here, where would it go? Straight over. Where's the orthocenter at? 0, 0. The orthocenter there would be located at 0, 0. Okay, remember, orthocenters can be either inside, outside, or on the triangle. In right triangles, they are the ones that are on the triangles. They're going to be right there at the right vertex, actually. Okay? Here is your assignment.